Hello students, welcome back. Previously in section 1, we went through some vector functions and their examples, and we saw the visualizations. We saw that vector functions gives rise to a curve, which we call the parametric curves. Now in section 2, let's consider some tangency problems associated to those. Let's see, here are some examples. Let's see, x is 3 cosine of t, y is 2 sine of t. So basically, we are looking for a vector function, 3 cosine of t, 2 sine of t, like this. Three cosine of t, 2 sine of t. Put together, here's a vector function, x comma y, and then t is going from 0 to 2 pi. So what do we have? We have this curve. That's a parametric curve given by this vector function or this pair of functions. You see this expression here, x and y are given as functions of t at pi over 3, this one here, and then this expression here, x of t, oh, sorry about that, x of t, comma y of t, is 3 cosine of t, comma 2 sine of t, like this, where t is pi over 3. This expression here and that expression there are the same. Here, I gave x and y as two separate functions. Here, I put together and made a vector function. Either way, they're the same thing. And then, what kind of calculus do we do? X is a function, y is a function, so we simply take the derivative. And then we have two components, so we have two derivative computations to do. In this case, what do we have? And then the vector function here is cosine of 2t, sine of t, and t is running from, I don't know, pi to pi. Pi over 2 to pi over 2. Okay, we have this kind of curve. Looks like it's a parabola. How about this problem here? So vector function x is e to the t power cosine of pi t, and then y is e to the t power sine of pi t, and then t is running from, let's see, 0 to 1. Okay, we have something like this. If you go to say 0 to 2, then as a matter of fact, it spirals further out. Spirals outward. I don't need that many. 0 to 1, okay, that's going to be sufficient because t equals 1/4 is already in this interval, so this is sufficient. Exactly where t equals 1/4 may fall, I'm not exactly sure. Probably around here, or maybe around there. How about the last example here? Two t plus 4 sine of 2t minus 2 square root of 3. T plus 2 cosine of 5t plus square root of 3. 0 to 2 pi. Okay, we have an interesting curve here. And then we want to do some tangency problem. We want to find out equations of tangent lines. We have done those for graphs. We have done those for implicit curves. Let's do that for parametric curves. That's the idea. Let's go back. In order to find out the equation of the tangent line, we need 2. Y equals m x minus x naught plus y naught. Oh, I take it back. We need 3. We need a point and slope, but the point, we need x0 value and the y0 value, these two, and then we need a slope. How do we find out the point? That's easy. X is given as a function and t is there, so if I plug in, I'm going to get x naught. Y is a function. If I plug in, I'm going to get y naught. Am I making sense here? X0, y0 are really easy to find out. 3 cosine of pi over 3. Yeah, I just plugged in pi over 3 right here. And what is this? 3 times cosine of pi over 3 is 1/2. So this is 3/2. How about y naught? Well, y is this function here, 2 sine of t, but I'm plugging in pi over 3. Okay, what is sine of pi over 3? Square root of 3 over 2. So this entire thing is square root of 3. So this one here is 3/2. This one here is square root of 3. That's what we got so far. So we don't know this yet, but this one we found out, 3/2, and that this one we found out, square root of 3. How do you find out the slope? Okay, now pay attention here, and then I'll take you back to this. Please remember this formula here, the slope formula. We need the slope point equation, all right? And slope is always the key. And how do you find out the point? Oh, that's easy. Plug in t0, I get x naught. Plug in t naught, I get y naught, all right? The derivative, on the other hand, x prime and y prime, those must be associated to the slope. It turns out, however, the derivative is y prime over x prime. Y prime x prime of t naught. How is that? Let me expand this font a little bit so that you can understand this. The slope is rise over run, remember? Rise is the difference of x coordinate, or difference of y coordinate, excuse me. Run is difference of x coordinate. Taking infinitesimal, we have dy over dx. That way you get the slope of tangent line. That's the same thing that we had been doing over and over again for 5 weeks actually. But here we use a chain rule here, which works just like the ordinary fraction. Instead of dy dx, the derivative, dy dt over dx dt, just like the ordinary fraction. And then what is dy dt? That's the derivative of y with respect to t. And down here, the derivative of x with respect to t. So y prime over x prime. So that's the slope formula. And of course, you have to evaluate it at given t naught. If you don't, you just get a function, not the slope. So that's the slope formula. You have to remember that. So here, finding x naught, finding y naught, that's easy. Finding the slope needs some work. We need to take the derivatives, get y prime over x prime, and then plug in the value. Can you do that? Well, let's go ahead and do that. X prime, what's the derivative? Here, x is cosine of 3 cosine of t, so negative 3 sine of t. Cosine becomes negative sine, and 3 is just coefficient. And then evaluated at pi over 3, what do you get? Negative 3 sine of pi over 3. Negative 3 times, what is sine of pi over 3? Square root of 3 over 2? Yeah, that's it. Negative 3 square root of 3 over 2. That's your x prime. Okay, y prime. What's the derivative? Y is 2 sine of t, so the derivative is 2 cosine of t. So far so good. Y prime of pi over 3 is 2 cosine of pi over 3. And then what is pi over 3? Cosine of pi over 3 is 1/2. So this entire thing is 1. Did I do this right? And remember, the slope formula is y prime over x prime divided dt over dx dt. So the slope is 1 over negative 3 square root of 3 over 2. So this is negative 2 over 3 square root of 3. That's my slope. That's the quantity that's going to go here. So this one here, let's put it here, and that completes the problem. This is where we're headed. First we find a point. Plug in t0, plug in p0, x0, y0. That's easy. We want to find out the slope. Slope is y prime over x prime dy dt over dx dt. So let's calculate the x prime. Take the derivative and plug in pi over 3. Calculate y prime. Take the derivative, plug in pi over 3. And you do your computation. Y prime over x prime evaluated at t0 value. We get that and then put it into the right place. That's going to be the answer. Here's a visualization. Indeed, we have the same slope. And then if you want to see the solution, again here, first the point, plug in. Second, calculate the derivatives. Alright, derivative computation, our bread and butter. Slope, y prime over x prime evaluated at t0 value. Plug in the values and do your computation. And then put everything into the slope point equation of the line. Okay, can you repeat that to all these problems? X, y, t0 value, x, y, t0 value. Here, x, y, and t0 value. All these. You think you can do those? Well, I did once. The other problems are left to you, at least for now. And in the next video, we'll come back and do some of these problems. Probably not all those, but some of those.